Let's solve the following linear inequation. Linear because we have only one variable x and its power is 1. Let's rewrite it. So we have negative 3x plus 12. This is less than 0. What we'll do? We will subtract 12 from both sides. So on the left hand side we have negative 3x. So this is going to be less than negative 12. Now what we'll do? We'll divide both sides with negative 3, and in doing so there is a small change that's going to happen. So we're going to divide both sides with negative 3. On the left hand side we have negative 3 and negative 3 cancelling out, so we have x. The sign of the inequality flips, so that means we have x greater than negative 12 divided by negative 3 will be positive 4. Now here the best way to remember this, we can say that the number 3 is greater than number 2. So whenever we multiply both sides with negative sign, let's say we're multiplying both sides with negative 1. So what happens? The sign should flip. And this will make sense because negative 2 is greater than negative 3. Okay, so this is the solution. So this is one way of representing the solution. The other way would be, so we will sketch a number line. This will be the real number line. So here we have 0 and 4. So on the number line, we will consider all values of x which will be greater than 4. So that means it extends from 4 all the way up to infinity, but 4 is not included here because x is greater than 4. That means we will put a bubble in here. So the bubble means that the number 4 is excluded. So this is one way. The other way can be, in the form of an interval, we can also represent the solution as for values of 4 goes all the way up to infinity, and it's going to be an open interval because 4 is not included, and infinity is always represented by an open interval. So these are the three possible ways of writing the same thing. So we have x greater than 4, we have in interval form the values between 4 to infinity, and on a real number line we can represent it graphically as all values of x greater than 4 with a bubble at the point